So this is the way the question will be written. Whoops. This is the way the question will be written for you guys on your test and your final exam. You won't be given the amplitude axis and all that sort of stuff. It'll be written. It'll be written just like that. So what we're going to do, the thing that you're going to need for these questions, the thing. Oh, there we go. All right. The thing that you'll need to know to pull all of the important information off this equation. So the stuff I'm not going to give you is this right here, the amplitude. You're going to need. I'm going to volunteer to tell me what the amplitude means in English and then what it is in this equation. What does the amplitude mean in English? Alan, go ahead.
That's the from the axis to max.
It's like the height of your wave, like the distance from the max to top. From this question, what's the amplitude going to be, please? Go over here. Count it going. It's 2. All right. So the amplitude is going to be the number in front. Now, if you think of this, if you weren't here yesterday, think of this like transformations from all we've done through the year, the f of the x. This would be like 2f of x. That's like a vertical stretch. That's what that is. So instead of the graph post going from 1 to -1, it's just going to go from 2 to -2. That's what that means. Okay. All right. Next is I'm going to do axis. Someone other than Cal, tell me what the axis means, please. Go ahead.
The vertical middle of the graph.
Vertical middle of the graph, very good. So that's just like the depth of the water, if you want to use that, okay, from that. Can someone other than Madison tell me, please, what the axis of this equation is, please? Go ahead. 1. Okay, great. Period is the next part. The period before, if you remember, was the distance. We made a whole note on this, was the distance over what the graph repeated. Okay? Can someone please, in this case, tell me how we calculate the period, please? Go ahead. 360 divided by k. Very good. What's the k value in this? 360 divided by 4. Now that's the horizontal compression. Think of this like f of 2x or f of 4x. F of 4x would be divide your x values by 4. Right? We're getting the same thing here. Your period, instead of going 360, is going to be 1/4 of that. 360 divided by 4 is in fact 90. I did my math right, which I think I did. Next is a word that I made after. Hope you guys understood this from yesterday. Action points. What an action point is just the distance from when the graph goes from the middle to the top to the middle to the bottom. It's just an easy way to graph your points on here. Can someone please tell me how I calculate the action points? I know 3 people that paid attention yesterday. Albert, go. 9 divided by k. Now, 9 divided by k, which is 90 divided by 4, which is going to be like 22.5. Now, again, the reason it's 90 is because if you're thinking of the unit circle, every 90 degrees is when it goes. Remember, the sine and cos relate to the circle, right? So the axis is going to be 0, the max is going to be 1, and so forth. Okay, great. What else do I need? Oh, phase shift. Can someone try and be brave? This is tricky. Amy, go ahead.
22.5 degrees to the right.
Very good. Now, where that's coming from is from the theta minus 22.5. Remember, the same as f of x. If you said f of x minus 22.5, that would be add 22.5 to x, thinking back to our transformations. So it's the same thing here, just going in the opposite direction. And the last part was, I'm not sure if I put this on the note or not yesterday. Where does the graph of cosine theta start at? At 1. I'm going to call that max instead of 1. Okay, so the maximum. Okay, now I'd like you guys to do this on graph paper if you have it. If you don't, find some from your friend. Okay, because on your assignment, I'll expect this in perfect graph paper, and on your test, I'll give it to you like all graphed up here. Then you know, talk about good graphs. Okay, this is one that when it looks good, it's really easy. So here we go. I'm going to do graph paper on the board here. Oops. Okay. So I'm going to get the graphic lined up here. Oh, goodness. there's my beautiful graph. I'm not actually doing this on purpose. I can't really make that line. I still can't, so I'm just going to leave it like that. Our axis is 1. Okay, so there's my lovely graph. We're going to do this like every graph, put nice arrows all over the place. There's my y-axis. Over here is going to be theta. Did it say to stay to the main range? If it didn't, we're going to anyway. It did? Okay. Now, for this one here, you don't have to go too far to the left. Remember, these graphs are periodic. We talked about those last week. They go infinitely in both directions, right? So I could, really, this graph could go on and flip to the right, to the left. I'm going to start around 0 and go to the right. That's just how I roll, as the kids say. Do you guys still say that? Okay. There's that. Okay, I'm going to show you the way that I did this, and hopefully you were shown this yesterday. What was the first thing you were told to graph yesterday? Axis comes first, okay? So number 1 is going to be my axis. So what I'm going to do, I'm going to count by 2's here. I'm going to go 0, 1, 2, 3, 4, 5, -1, -2, -3. Okay, so the first thing I'm going to do is I'm just going to draw a nice horizontal green line, conveniently. Go something like this. I'm going to call that the axis. Now mine, of course, would be nicer than yours and faster because I'm doing it on computer. Okay, right? But that's going to be the middle of your graph. Okay, so we'll be working up and down from there. This is looking sort of familiar from yesterday, I hope? Yes?
Yeah, it was confusing when you find the maximum and frame rate going and using the amplitude function.
Yes, right on. So the amplitude number is 2, and that's actually the second thing that we do. So what I'm going to do is, this means 2 up and 2 down from your axis. Okay. So can someone other than Madison tell me please what my maximum for this graph is going to be? Okay, the other Madison, go ahead. 3. Okay. And you got that, I hope, because we just added 2. Okay, right, so we start the maximum went up 2. Julia, can you tell me what the minimum for this graph is going to be now, please? -1. Now remember, this is supposed to be symmetrical in a way. Okay, so the, oh goodness. So the axis is supposed to be in the middle. So it's supposed to be the balance on both sides. Where some people go wrong on this, they'll go down to -2. They'll think it's 2 down from 0. Okay, well if one's got to be in the middle, you can't go from 2 to -2, right? Because that's not in the middle. Are we good so far? Daniel, all right? Okay. Next thing, number 3, is going to be action points. Now, what an action point is, it's basically every hash mark on my graph, left and right. Every square on the graph is going to be an action point. So I'm going to, oh goodness. I, of course, did 22.5. Okay. My graph's only going to go to 135 and -22.5 over there. Okay. If you want to use every other one and just put a dash and do 45 and maybe just a dash in between, that's fine. Okay, now this is the time to ask questions because this is tricky for people. Those are all so polite and nice, especially those that were absent yesterday. Yes.
Okay, with phase shift, what do you mean 22.5 degrees?
Okay, so all it means is that cosine normally starts, the graph of cosine at 0 degrees hits at the max. Okay, so what the phase shift means now, instead of at 0 degrees it hits the max, it's going to hit the max at 22.5 degrees. Okay, so, and that's going to be the 4th, and I'll do this in right now. That's going to be the segue. Number 4 here comes here. I'm just going to put a little dotted line. You don't have to do this if you don't want to. But this is going to be my start. So that's your phase shift. Okay, just shift it over 22.5 to the right. All right, I would like someone to be brave. The people I am voting out of this are A, B, C, D, and E. You raise your hand every question. So you're D, okay? So those 5 people are out. Can I get some new person to be brave and tell me where the first point on my graph is going to be? It's supposed to be at the max because it's cosine. Go ahead.
A, 3, 1.
Good. 22.5 is going to be your theta, and then it's going to start the max. And then cosine start at the max. Can I have another one? Good. Okay, can I get someone else that's brave? I know even A, B, C, D, and E come back in here. I'm going to pick on Ben because he was looking surly at the back of the class today. Ben, what's the next point to the right going to be, please?
1.5.
Good. It's actually 45 and 1 next one's 4y, but I know what you mean. 45 and 1. Good. Can someone else be brave and tell me what the next point's going to be? Go ahead. Now, the thing to note is that every point's got to be the same distance, right? Like every square is the same distance across. And this is something people were asking a question from the homework from last night. The number 3 had a weird one like this, and they thought 22.5 seems weird. As long as it's all consistent, like every square could be 1.6 or 13.4 or next year pi by 4. Just wait. Don't be afraid. It's good. All right. Can someone else be brave? What's the next point going to be? To the right. Go ahead. That's you. That's you. Yeah.
1 and 9.
Good. 90 and 1. Yes. And the fifth person, what's the next point going to be? Go ahead. Okay. And the next one's here. Now let's get people that are really brave. Cameron, I'm picking on you. To the left now. What's the next point to the left going to be? Curtis. Where are you, Cameron? All right, Curtis. Didn't I do that earlier in the year too? What did I call you beginning of the year? Curtis. Go ahead. What's the next point to the left here? Yeah. So if this point's here, what's the next point going to be to the left? Good. Not negative 22. Right? It's going to be at 0 then, right? Just that number 1. Georgie, the next point to the left is going to be what? Let the real brains push. If I wanted to go to the left again, even though there's no room on the graph, what would the next point be to the left? Go.
Would it be 1 and negative 45?
Good, right? And this goes on forever. So make sure when you do this graph for yourself, if I don't tell you what to graph from, you can graph as big or as small as you want, right? Because I didn't actually tell you. Doesn't that make you feel good that way? Oh, I feel like the beach right now instead of when it's minus 15 out today, okay? But there's that. Isn't that a beautiful graph? I'm so happy. Let's put a title onto this, which is going to be y equals 2 cos 4 theta minus 22.5 plus 1. All right, domain and range. Taylor, I'm picking on you. What's the domain for this graph, please? Very good. Hey, can I get someone else other than Taylor to be brave? You can take it if you want, Taylor. And give me the range.
Less than 3, greater than 1.
Good. Excellent. And that's what you did yesterday, hopefully. Okay. For those of you here yesterday, that was the same, I hope. Yeah. Good.
Why is that theta instead of x?
Oh, because we're dealing with theta instead of x. No, I'm probably not going to be clinical, okay? But just since we're dealing with angles here, I use theta. Right? So, Lily, how you doing? Okay, so the way math works is that I'm going to pause the video and tell my story over